Okay, so we're going to get started. So this video is going to talk about graphing of all different kinds of polynomials. And we're actually going to just kind of start at the beginning and go through and show you how it kind of makes a pattern of the different graphs, going all the way from lines up to cortex. So let's go ahead and get started. Your criteria that you should be looking at, guys, as you go through here is that you should be able to identify what type of graph it is or a function it is from the graph. You also should be able to explain all the basic shapes for all the functions. You need to talk about the x-intercepts and how it affects the shape of the graph. We're going to find our local maximum and minimum, and we're going to talk about the end behaviors. And then we'll state the number and types of roots. So there's quite a bit on here. It's probably going to take a couple of videos to get through all of this. So I will try to not have it last too long. So let's go ahead and just get started. Again, there's a list of words, and we're going to talk about almost all of those in there. If there's something when we're done that you don't understand, please holler. So we're going to go back to, again, talking about our x-intercepts. Our x-intercepts when we graph, especially higher order polynomials, are going to become very, very important. We've talked about that all year long, how you've got to know how to find your x-intercepts and your y-intercepts. So again, remember your x-intercept is the point where your graph crosses the x-axis. And again, I expect it to be written as a point. It is where y equals 0. And so it should always be the point something 0. And some of these are going to have more than one. You know, lines had 1, quadratics could have 2, cubes are going to have a possibility of 3, quartics 4, so forth on there. So remember, the key, guys, is anytime I ask you to find me the x-intercept, y equals 0. Okay, the next then again is the y-intercept. It is the point where the graph crosses the y-axis. Again, it is where x equals 0 all the time, and we write it as a point. So again, do not forget that. A lot of times it is, if it is written in standard form that we just did our last video over, it will be your last number, your constant term. Okay. So generally it will be your constant term, because when you put in 0 for all the other x's, that's what's left. Sometimes it's too big that we can't put it on a graph, so I don't expect you to graph it all the time if it is such a large number or such a small number. Okay, we're going to talk about local maximum and local minimum. I'm just going to give you a sketch of the graph here to tell you what we're looking at. So if we're looking at, in particular, cubics, okay, that's a good one to look at. So if a cubic, and I'm just going to sketch a graph here, okay, so this would be a cubic. It crosses 3 places. And if I actually talk about the maximum value, well, technically this is the maximum, right? It's going to just keep going on and on forever. But that's not really what we're looking at. When we talk about local maximum, it is the other point on your graph that is a max. So in this case, my maximum would be right here. This would be my local maximum, okay? So it is the highest point that is not how your end behaviors are doing, okay? For the most part, what we're going to be doing is putting that in our graphing calculator or on Desmos and looking at that point to find it, but we will kind of talk about how you can find it without that. Then you've got your local minimum on there, which again, this would be your minimum would be the extending on forever, but your local minimum would be your lowest point here, okay? So again, the same way we'll be finding that. So even though this is your minimum, that it goes to negative infinity. Again, your max goes to positive infinity. Those are your local minimums and your local maximums that we're talking about. Okay, the next thing is repeated solutions. And what does that tell you? So what we mean by repeated solutions is, let me give you some examples. If, and I'm just gonna work with cubics, I guess. That'd be an easy one to work with. But let's suppose I'm just gonna make up some values. X minus 1. So if I solve this here, this would hit at -1, -2, and 1. And so each one of these has a odd power, okay? Odd power or odd exponent. And what that means is that it goes through x-axis. So what I'm talking about when I look at this graph and I put my points at a -1, -2, and 1, okay, my graph is going to go through those points. See how it goes through? So that's what we mean if it's to an odd power. Now that power could be a 3, it could be a 5. It's still going to be the same way. It's going to go through. Now if I have a cubic though that has x plus 1 squared, we'll do that, and we'll do x minus 1. So this would be x equals a -1, and we would say it has a multiplicity of 2. Okay, multiplicity of 2 because it occurs twice. And then this would be x equals 1, again, which is an odd. So what happens then if it is an even power? Okay, we say it touches and bounces. Okay, so what that one would look like, we'll come over here, is I have a -1 point and I have a 1 point. So the 1, so I know here this one is going to go through and this one is going to touch and bounce. So I'm going to touch and bounce at a -1, and sometimes I'll put TB, touch and bounce, and go through, however you want to do it. So what that means is I'm going to come up, I'm going to come up, I'm going to touch and bounce, come down, and go back through. Okay, so that's what I mean by touch and bounce. It's not going to go through. So the key here is to remember on repeated solutions, if it has an odd power to it, 1, 3, 5, 9, it doesn't matter what it is going to go through the x-axis. Okay, if it has an even power, then it's going to touch and bounce. Okay, and so I will ask you that over and over. Okay, so be sure you remember those.